All right, you guys, I hope that your water quality lab went well. We are going to talk about water cycling on the earth and watersheds, reservoirs, processes, and human impacts, and then kind of work our way into talking about groundwater and how pollution can move through groundwater. That's going to set us up for this sweet lab that we will do next week when I get back. So please go ahead, like usual, write down stuff in blue in your notebook, and you can pause the video at any time that you need to before proceeding. All right, the first thing I want you to do is draw this diagram and label it. So you're going to look at the different phases of water, the processes that happen to change the phases. So is it evaporation or condensation? And is it a gas, liquid, or a solid? And this is going to really help you kind of think about the movement of water through the water cycle. And you guys are familiar with the water cycle. You've seen it before. If you don't remember, there's a really baller episode of the Magic School Bus, the original Magic School Bus, that talks about the water cycle. So you could go ahead and watch that to review. Then I want you to write 3 to 4 sentences explaining how water moves between different places in the earth. Include the role of energy in the process, so energy from the sun, and then you can talk about gravity and how gravity moves water and some of those different pieces. Okay, so I'm going to be looking for this in your notebook when I get back on Monday. So pause the video, take some time to do a really nice job with this diagram. Okay, so normally we would do this as a think, pair, share, but since I'm not there to facilitate, what I'd like you to do is to do it as more of a right pair share. So answer these questions in green in your notebook. So what is the difference between a reservoir in the water cycle and a process? And then give an example of each. Which letters in the diagram represent processes? And which reservoir do you think holds the largest amount of usable fresh water on the earth? Do you think it's snowpack, rivers, lakes, or groundwater? So fresh water, not the ocean. Okay, so pause the video, take some time to do this on your own, and then maybe turn to your shoulder partner and see if they've gotten to this part, and maybe you guys can talk about it together. Where does Fort Collins get its water? So the Fort Collins water is part of the Poudre watershed, and a watershed is an area of land that drains to a body of water. So in our area where we live, all of our water ultimately drains to the Poudre River. So, excuse me, the Spring Creek drains to the Poudre River. All of our drainage ditches and all that stuff drains to the Poudre River. And so there's kind of this elevation map. We've got really high elevation to the left and lower elevations to the right. And all of that water is just draining into the Poudre River. So Fort Collins gets its water from the Big Thompson, Colorado Big Thompson project, including Horsetooth Reservoir. So the Big Thompson River actually feeds Horsetooth Reservoir, and then the Cache-la-Poudre watershed. So the Cache-la-Poudre watershed is in Colorado and Wyoming. It covers 6 counties: Grand County, Jackson County, Larimer County, Weld County, Albany County, and Laramie. It flows downstream into the middle South Platte Cherry Creek watershed, which is to our southeast. Here is kind of a map of the Colorado Big Thompson project, including Horsetooth Reservoir. And I just think it's really interesting to look at how the water has kind of been diverted and then ultimately ends up in the South Platte. So there's a lot of different parts of the Poudre River. We have kind of a calmer part of the Poudre that is more of through Fort Collins. There are parts of the Poudre in the canyon that are very steep with a lot of rapids. There's parts of the Poudre in the canyon that are calmer but still very rocky, and so there's some really distinct environments that the Poudre River runs through. Looking at a watershed more broadly, we can think about the different components of it. There's snowpack, which is generally in the mountains. This is a reservoir. This holds our snow, and it serves as a water source and natural storage. When we have snow melt, that's when we start to see some real movement of our water as our snow melt makes its way down out of the mountains to the plains. Glaciers are also a large component of watersheds. They're a large mass of ice formed by the compaction and crystallization of snow. So the snow is just getting squished down and kind of solidifying almost into just this really icy mass. This is also a reservoir. These are powerful agents of erosion. And next week, we're going to start really talking about weathering and erosion. And so we'll talk about glaciers again. Glaciers often sublimate, so they go from a solid to a gas. So the frozen water in the form of ice and snow is receiving energy from the hot sun, and it just goes immediately to a gas. And this happens right here in Colorado. So they move down a slope under their own weight. Glacier calving is the breaking off of ice chunks from the end of a glacier into a body of water. If you follow the link that I posted on Google Classroom that you see below, you can see some pretty neat footage of a glacier calving. On the right-hand side here, you have some pretty interesting photos of a glacier in Glacier National Park. I recommend going to Glacier National Park like this weekend if you want to see some glaciers, because the glaciers are very rapidly receding. So just over the course of 60 years, a glacier that had been there for hundreds of years melted very, very significantly. If you think about the scale of these mountains, especially. And so that's a result of our changing climate, and we'll get into that more in our next unit. Forests act like a sponge. They're a big reservoir of water. They act like umbrellas. The leaves break the water droplets. They act like nets. The roots hold the soil in place, and they act like blankets because they drop their leaves and it protects the soil. And all those things really hold the water into the soil. It breaks the water droplets up into smaller particles so that they can really saturate the ground, and then the leaves protect the water from evaporation. So this is another important reservoir. Grasslands and plains are also sponges that soak up water, so they act as a reservoir. The grasses and the roots really retain a lot of water, and so all of our grassland and plains that we see around the Fort Collins area are acting as reservoirs. We have lakes, which can be natural, or reservoirs like Horsetooth that are human-made, that act as water storage. So they are also reservoirs. Literally, one of them is called a reservoir. So you can have naturally occurring lakes like Dream Lake, or you can have reservoirs like Horsetooth Reservoir, and they both store water. Impervious areas are an important component of a watershed because they are structures or surfaces that are covered with an impenetrable material, such as roads, parking lots, sidewalks, rooftops, or rock outcroppings. And so this is really a process that causes the water to run off or erode something and cause changes over time. These can carry pollutants to water from cars or factories. They block drainage directly to the soil, and they redirect water flow. So these impervious areas can have a really big impact on a watershed. So we're just going to briefly get into weathering and chemical weathering. But we're going to go into more detail next week. So we're looking at what happens when water comes into contact with its surroundings in a watershed. And so we can have physical weathering, which is when something, whether that's wind or water, like physically rubs away at the surface of the rock, and we can have chemical weathering, which is where a chemical reaction is occurring that's causing the surface of the rock to change. So they both really result in changes in the shape of the rock, but their processes are very different. Chemical weathering is the breaking down of rocks due to chemical reactions between the minerals and rocks and the environment. And water hydrolysis, acids, which is carbonation or acid rain, and oxygen, which is oxidation, can change the chemical composition of rocks and minerals. So this is a big deal. You're changing what the rock or mineral actually is. And these are most common in hot, wet climates. Physical weathering is very different. So it's also called mechanical weathering. So it breaks the rocks apart without changing their chemical composition. So the same type of rock, they're the same type of substance, but they've just changed their shape. So there's some pretty distinct examples at the bottom here. Frost wedging and root wedging, thermal expansion and contraction and erosion are all examples. And these are common in cold and in dry climates. Groundwater is subsurface water in a zone of saturation, and that's where all of our usable fresh water on Earth is from. So 98% of fresh water is below the Earth's surface. All pores and spaces underneath what we call the water table are filled and saturated with water. So the water table is this line, and everything beneath that line is filled with water. That's why people would dig wells, to get through the water table, and they would get all that water into their well. And any underground water layer in which water can flow is called an aquifer. So when there's a lot of little holes in spaces in between the rocks and the soil making up the ground, then the water can flow underground, and that results in what we call an aquifer. So porosity is the volume of open space in a soil or rock sample. Permeability is the ability of material to transmit the fluid. And infiltration is the seepage of water into soil or rock over time. And so different conditions really result in very different groundwater scenarios. So I want you to take a minute and consider both of these pictures and identify 3 similarities and 3 differences between water systems A and B. Pause the video now. Okay. Water quality is a really crucial factor in the quality of our lives, and so water quality decreases sometimes due to natural or man-made contaminants. Hard water is caused from calcium bicarbonate picked up from the landscape or the environment. Leachate is water that ran through contaminants, and it picked up a lot of soluble substances and chemicals. So it's basically just filthy water. So think about, what does it mean to be soluble? What are probable sources of contamination in our groundwater? And write those answers down. Okay. Last but not least, we want to think about different sources of contamination and how they might move through our groundwater. Fracking has been a really controversial topic recently, and so this diagram kind of takes you through how fracking works, and the idea is that this is happening underneath the groundwater, and so the groundwater is really safe because there's impermeable rock between the fracking and the fracking chemicals and the groundwater. The pipe does pass through there, but the idea is that the pipe is solid cement, and so the water is safe. There's a lot of controversy about whether or not those claims are true. So go ahead and write in your notes, what's the purpose of fracking, how is fracking related to groundwater, and what are some potential problems caused by fracking. Pause the video and go through that analysis. Okay. Last, we want to talk about influent and effluent streams. Influent streams are common in arid environments where the water table is really deep. So it rains, and then that rain seeps into the ground, and then the stream dries up. So this stream feeds the aquifer. Effluent streams occur in wet, temperate environments where the water table is at or above the height of the river. So this means that the water table is feeding the river. So the river isn't going to dry up unless the entire aquifer dries up. And northern Colorado has both of these types of streams since it's a semi-arid climate. All right, next week we're going to do a groundwater lab and start really thinking about how pollution interacts with groundwater. Thank you for sitting through this lecture and writing yourself some notes. I'll see you next week.